Okay, in this part of the lecture, we will talk about scientific notations and significant figures. What is a scientific notation? Well, scientific notation is a shorthand way of writing very large and or very small numbers. As an example, for example, if you were to write the radius of the sun, it is about 700,000 kilometers. So in terms of scientific notation, we can rewrite this as 7.0 times 10 to the 5 kilometers. Similarly, if you were to look at the radius of a hydrogen atom, it is 0.0000000000529. So if you were to write that again and again and over again, it will take you a long time to come up with an explanation or come up with an answer if it involves more than one step. So scientific notation makes our life easier, and we are able to rewrite this long number by 5.29 times 10 to the minus 11 meters. Note the difference between a really large number and a really small number. See, there is no minus sign with this. That means it is a big number and we are supposed to multiply it with that many zeros. If you see a really tiny number, you'll see a minus sign that goes along with it. What that means is that you have to divide the first number by that many zeros. So that means in the 7.5 times 10 to the minus 5, what you're doing is you're multiplying the 7.0 with 10 to the 5. That means 100,000 kilometers. Whereas if you are to take the lower number, which is 5.29, what that means is you are supposed to divide that with 10 to the power 11 numbers. In order to understand this more correctly, let's look at an example. Write in scientific notation. For each quantity given below, rewrite in scientific notation. So the quantity A is 0.00004048 meters. So now notice, since this is after the points, this should be a tiny number. So go ahead, pause for a minute, and pause this video for a minute, and go ahead and rewrite this in scientific notation. What do you think the answer should be? Well, for me, I think the answer is 4.048 times 10 to the minus 5 meters. See how this goes over 1, 2, 3, 4, 5 digits. So you're skipping 5 digits, and that's where the 5 comes in from. Go ahead to part B. This is my answer, 5.24 times 10 to the minus 2 grams, which basically means is I am moving this over 2 decimal places. Okay? Now, this is a big number, 95,000, so it's 950,000 kilometers, right? So how will I write that in scientific notation? 9.5 times 10 to the 5. Now note the difference between big numbers and small numbers. We've talked about this before. So go ahead, write the part D again, 142.452 pounds. Yes, it is going to be 1.42 times 10 to the 2 pounds. So next we need to talk about significant figures. As we improve the quality of our measuring instruments and the sophistication of our techniques, we carry out these experiments at ever increasing levels of precision. We can extend the measured result to more and more significant figures and correspondingly reduce the experimental uncertainty in our result. Both the number of significant figures and the uncertainty tells us about our estimate of precision in the result. Let's look at x equals 3 meters. So our answer is x equals 3 meters. Now what does that mean? It means that we are saying that the value that we evaluated lies somewhere between 2 and 4, but it's closer to 3. So we approximate it to be 3. On the other hand, for x equals 3.14159, which I hope you all recognize as the value of pi, means that the probability of our answer lies somewhere between 3.14158 and 3.14150. What that basically means is that we are to the first 5 digits, we are very sure of what the answer is, and in the last digit, we are not so sure. So our uncertainty has increased, our uncertainty has decreased, and our certainty in our answer has increased by that factor. So let's talk about most significant digits and least significant digits. Most significant digits, by definition, are the digits in a number that have the greatest effect on that number. By changing that one number, you can change the whole answer by a huge amount. Least significant figures or least significant digits are those digits that have the least effect on the number. Least significant digits are generally the lowest in a number, located towards the far right of a string of numbers. So for example, if you were to look at 2006, in this case, 6 is the least significant digit. What do you think is the most significant digit in this example? Correct. It is the number 2. So suppose I change the number 2 to a number 3. That means I am changing it to 2006. Now, if I change number 6, for example, to number 5, I'm changing it by only one number, 2005. So instead of 2006, I have $2,005. Get it? Okay. So now, stare at these for a little bit. Which numbers do you think are the most significant and the least significant? So for the first one, it's 1876.0. Obviously, the most significant digit is the first one, the 1. But you would have assumed that the least significant digit is 0.0. We have to be careful in this case. Those can be placeholders, which means that all they're doing is telling you where the decimal point lies. They might actually not be included in your evaluation or in your experimental result or in your value. So we have to be very careful about these. Look at the second number, 357.089. In this case, the 3 is the most significant and the 9 is the least significant. Note, in this case, you cannot ignore the 0 that's in the middle. Now look at the last one, 0.058927. In this case, 5 is the most significant and 7 is the least significant digits. Now, this all may seem very random to you right now, but there are certain rules that make our life easier when we talk about significant figures. So, the rules for figuring out scientific notations are as follows. Rule number 1, count from the left, ignore leading zeros, keep all digits up to the first doubtful one. For example, x equals 3 meters has one significant figure. Expressing it as 0.003 kilometers does not change the number of significant figures. It is still 1. However, x equals 3.0 has two significant figures, as we actually may know the value of x equals 3.0. Careful. X equals 300 meters does not indicate whether there are 1, 2, or 3 significant figures, as if we don't know if the zeros carry any information or are they serving just as placeholders. So please be careful when you are solving for this. To specify more precision, we should actually rewrite this as 3 times 10 to the 2, or 3.0 times 10 to the 2, or 3.00 times 10 to the 2. Writing it in this way helps us do is figure out whether these numbers are actually significant or are they just being used as placeholders. For example, 3.10 is 10 to the power 2 means that we only know that 3 is significant. 3.02 actually implies that we know that the first digit is 3.0. Or 3.00 implies that it now has 3 significant figures because we actually know the value of 3.00. So just be very careful when you are solving for this. Rule number 2. When multiplying or dividing the number of significant figures in the product or the quotient should be no greater than the number of significant figures in the least precise of the factors. Now that's saying a lot, but what it basically means is if you were to plug in 2.3 times 3.14159 into a calculator, you will get something like 7.25675. Is this actually correct? Is this the number that you should be coding as an answer? And the answer is absolutely not. Because the number of significant figures and the least precise number is 2.3. That's two significant figures. So our answer should not have more than two significant figures. Okay? Same thing, 9.8 times 1.03. Now here you get 10.1. But I just told you that 9.8 is the least significant of these numbers, and I'm multiplying these two. Now here's where things become a little fuzzy. But even though 9.8 technically has only two significant figures, it is very close to being a number with three significant figures. So the product, it's okay for you to express it with three significant figures. Rule number 3. In adding or subtracting, the least significant digit of the sum or difference occupies the same relative position as the least significant digit of the quantities being added or subtracted. Now, what does that mean? What that basically means is, if you were to add 103.9, 2.10, and 0.319 kilograms, for example, all together by hand, what you would do is you would write them in a straight line in such a way that the decimal points all line up. Okay? And then you can start adding from the right hand side. So your answer should be 9, 1, 9, 10, 11, 12, 13, 3 and 1 will get carried over, and this will be 6, 0, 1. So it will be expressed as 106.319 or 106.3.